Bismillahirrahmanirrahim. I welcome class 10th in my lecture series for chemistry. In today's lecture, we are going to study about the sources of organic compounds. The major commercial sources of organic compounds include coal, natural gas, petroleum, living organisms, and they can also be synthesized in laboratories. Now, moving towards our first source, that is coal. What is a coal? Coal is a black rock that is obtained after the process of mining. Now, when this black rock is obtained, it is decomposed at higher temperature to get certain substances that are useful to us. But first question arises that how the coal is formed. Millions of years ago, when the giant plants died, the dead remains of those plants remained on the surface of Earth for a longer period of time. The microorganisms present on those areas began to decompose the dead remains of plants. And after the decomposition of those dead remains, the decomposed products get buried deep into the earth. And under the increased pressure and temperature in the deep regions of the earth, they got converted into coal. Here you may see that there are certain plants. When these plants died, they remained on the surface of the earth for a certain period of time. After the passage of time, when they started moving deep down the earth's surface, then at increased heat and pressure, they first got converted into peat. After the passage of some more time, at increased heat and pressure, they got converted into brown coal. And this brown coal then got converted into the black coal. Now, after the formation of coal, then this coal is extracted with the help of a mining process that may take place on the surface of the earth, or that may be the underground mining. Now, when we got the coal, then the next step is the destructive distillation of that coal. Destructive distillation means that the coal is decomposed at higher temperature in the absence of air. Now, when coal is decomposed at high temperature in the absence of air, it got separated into three fractions. First one is the coal gas. The composition of this coal gas includes the methane, hydrogen, and carbon monoxide. This means that these gases are present in the coal gas. What are those gases? Methane, hydrogen, and carbon monoxide. This coal gas is used as a fuel in industry. The second fraction that is obtained from the coal is the coal tar. This coal tar is a blackish fluid. Chemical composition of coal tar includes the benzene and its derivatives. And these derivatives are further separated by fractional distillation. What is benzene? Benzene is an organic compound and it has a closed structure like this. It has a closed cyclic ring and contains 6 carbon atoms as well as 6 hydrogen atoms. As you may see here that there is the presence of 3 triple bond in this structure. This benzene is also called as aromatic hydrocarbon. We will discuss about aromatic hydrocarbons in our upcoming lectures. Third fraction
of coal The combustion of fuel in the absence of air is called destructive distillation of fuel. Objective: to understand destructive distillation of coal. Arrange the apparatus as shown. The horizontal glass tube contains some crushed pieces of coal, while the vertical glass tube is filled with some amount of water. Heat coal over a burner. On strong heating, it produces colorless vapors which enter water filled in the other tube. After some time, few of these vapors condense to form black viscous layer below the water level. This is called coal tar. While some other vapors get dissolved in water to form a colorless layer above the coal tar layer. This colorless layer is called ammoniacal liquor, as it mostly contains dissolved ammonia. Lastly, the unreacted vapors are released through the outlet of this tube, called coal gas, which is combustible. The material left behind in the horizontal tube is called coke. Coke contains about 60% of carbon. When hot steam is passed over coke, carbon in the form of coke reacts with water vapors to form a mixture of carbon monoxide and hydrogen, which is called water gas. It is used in the manufacture of hydrogen gas. Coal gas. Coal gas is mainly a mixture of methane along with hydrogen, carbon monoxide, and other gaseous hydrocarbons, and is used as an industrial fuel. Ammoniacal liquor is mainly used to manufacture fertilizers. Coal tar is mainly used in the manufacture of dyes, insecticides, medicines, artificial yarn, etc. Summary: destructive distillation of coal produces coke, coal tar, ammoniacal liquor, and coal gas.
Another source of organic compounds is the living organism. We know that these organic compounds can also be derived from animals as well as plants. From animals, we get proteins when we consume eggs, mutton, chicken, beef, or fish. Similarly, we also get fats or oils when we consume milk, butter, or cheese. Now, these proteins, fats, and oils are the organic compounds. Plants also are the source of these organic compounds. They give us carbohydrates when we consume wheat, maize, potatoes, barley, and rice. When we consume pulses and beans, then we get proteins. When we consume apple, banana, and orange, we get vitamins. And these plants are the source for different oils like palm oil, olive oil, soya bean, peanut oil, sunflower oil. Now, all these substances contain different organic compounds that are beneficial to our well-being. So, therefore, these animals and plants are also the source of organic compounds. Now, what is petroleum? This petroleum is another source for the organic compound. The word petroleum comes from the Latin word petra, meaning rock, and oleum, meaning oil. So this means that this is an oil that is obtained from a rock. Petroleum is also called as the crude oil, and it is basically the mixture of hydrocarbons that contain compounds having carbon number ranging from 1 to 40. Now, how the petroleum and natural gas is usually formed? Tiny marine plants and animals died and were buried deep on the ocean floor. Over time, the marine plants and the animals were covered by layers of silt and sand. Over millions of years, the remains were buried deeper and deeper. The enormous heat and pressure turned their remains into oil and natural gas. Today, we drill down through the layers of sand, silt, and rock to reach the rock formations that contain oil and natural gas deposits. So this means that the petroleum and the natural gas are the fossil fuel since they are derived from the dead remains of the plants as well as the animals. Now when we get the petroleum, we know that it contains the mixture of hydrocarbons. Now we need to separate those hydrocarbons because each hydrocarbon has different usage. So how will we separate these hydrocarbons from each other? The process of separating these hydrocarbons from each other in a petroleum is called as the fractional distillation. What actually happens in a fractional distillation? That we are separating these hydrocarbons on the basis of difference in their boiling points. So fractional distillation is a process in which mixture of hydrocarbons are separated on the basis of difference in their boiling points. As you may see here in this diagram, that the mixture of hydrocarbons, the fraction of the petroleum that has the boiling point below 25 degrees C is when separated, it is used as a petroleum gas. The fraction of petroleum that that has a boiling point in between 25 to 60 degrees C is used in the gasoline, is used as a gasoline. The fraction of the petroleum that has the boiling point range between 60 to 180 degrees C is used as a naphtha, and so on. The last fraction of the petroleum that has the boiling point around about to 350 degrees C is used as a bitumen. It is used on roads. So this is how different fractions of petroleums are consumed for different processes. Let's see a short video on the fractional distillation of crude oil.
In today's video, we're going to take a look at crude oil and see how we can separate it into its different components using fractional distillation. Crude oil is a fossil fuel that we get from deep under the ground and is basically a mixture of lots of different compounds. Nearly all of these compounds, though, are hydrocarbons, which contain only hydrogen and carbon. And the most common type of hydrocarbons are alkanes, which we covered in the last couple of videos. Now, crude oil is formed naturally from the remains of dead plants and animals, particularly plankton, that died millions of years ago and were buried in the mud. Then, in the millions of years between then and now, the high pressures and temperatures under the ground turned this organic biomass into crude oil. As it formed, this crude oil soaked into the rocks and was stored for millions of years. But we can get it back out by drilling into the rock and sucking it up to the surface. As crude oil takes so long to form, it's effectively a finite resource. And if we continue to extract and use it at the rate that we are now, then one day we'll run out of it completely. This is why we refer to fossil fuels like coal, oil, and gas as non-renewable fuels. Once we've extracted the crude oil from the ground, we need some way to separate out all of the different hydrocarbons in the mixture, because they each have different properties, and so we'll use them for different things. To do this separating, we use a process called fractional distillation, which involves heating the crude oil up and separating out the different compounds by making use of the fact that the different compounds all have different boiling points. The first step is to feed the oil into a chamber and heat it until most of it has turned into a gas. We then pass this gaseous mixture into a fractionating column, which is really hot at the bottom, but gets cooler towards the top. The idea is that these hot gases will then start to rise up the column. But importantly, as soon as they reach a region that has a lower temperature than their boiling point, they'll condense into a liquid. The hydrocarbons with the longest chains, so the most carbons, have the highest boiling points, and so they'll quickly condense back into a liquid and drain out of the column early on, because it's not hot enough to keep them in their gaseous states. These are things like bitumen, which we use to surface our roads, and heavy fuel oil, which can be separated further and used for things like heating oil, fuel oil, or lubricating oil. The shorter chain hydrocarbons, though, have much lower boiling points, so they'll stay as a gas for much longer as they rise up the column until they finally reach a cool enough temperature that they condense into a liquid. This gives us fuels like diesel and petrol, which we use in cars and other road vehicles, and kerosene, which is used in jet engines. Some hydrocarbons, though, are so short and have such low boiling points that they stay as a gas the entire time. For example, LPG, which stands for liquefied petroleum gas, contains mainly propane and butane, which are both very short chain alkanes. If we compare these different groups or fractions, the ones towards the top, which are the shorter chains, are the most flammable, and so they tend to make the best fuels. Meanwhile, the longer chain hydrocarbons, here at the bottom, are often poor fuels, so are instead either used for something else, or can be broken down into smaller hydrocarbons in a process called cracking, which we'll take a look at in the next video.
Now, let's study about the difference between the fractional and the destructive distillation. Destructive distillation is a chemical process that involves the decomposition of a solid by heating it in a closed container and collecting the resultant volatile constituents. So this means that in the destructive distillation, as we have read before, we used coal, and that coal was a solid, and that solid was heated in the absence of air and was decomposed into different fractions. Fractional distillation is the process which is used to separate hydrocarbons component in the crude oil or the petroleum. In the destructive distillation, there is a process called the decomposition of a solid, whereas in the fractional distillation, the components are separated according to their difference in their boiling point. In the destructive distillation, an apparatus includes two test tubes connecting to each other via side tubes and containing coal and other containing water, as you have seen it in the video. Whereas the fractional distillation consists of fractional distillation column, a condenser, and two containers. Destructive distillation is mainly used for coal distillation, whereas the fractional distillation is mainly used to separate constituents in the crude oil. Another source of the organic compound is the natural gas. Natural gas is a mixture of low boiling hydrocarbons. As you have seen in the video of fractional distillation, that these low boiling hydrocarbons are very flammable. So they may be employed as a fuel for heat generation. Now the composition of natural gas is mostly methane. It contains major amount of this organic compound, that is methane. Ethane, butane and propane are also present in the smaller amounts. Another way to get the organic compound is by synthesizing them in the laboratories. Over 10 million compounds have been prepared, and these compounds are used in the medicines, cosmetics, plants, plastics, fertilizers or detergents. As you must have read before, that in the ancient times it was thought that the organic compounds can only be derived from the living organisms. But the Frederick Wohler synthesized an organic compound, that is urea, from an inorganic compound, that is ammonium cyanide. So what he did, he basically synthesized an organic compound in the laboratory. Now we have developed different synthetic schemes to synthesize many organic compounds, and most of these organic compounds are employed in the synthesis of medicines and the drugs. So in today's lecture we discussed that from which sources we can get these organic compounds and what are the uses of different organic compounds. So this was all for today. Thank you for being with me.